Can everybody hear me okay? All right, I apologize. We'll get the echo fixed here in a second. I just wanted to go ahead and thank Spinspire for continuing to host us, providing food. And also wanted to thank Jason Gerard for coming out tonight to do this presentation. So I saw a presentation that Jason did on Kubernetes earlier this year. And I asked him if he would come and do a presentation on it for tonight. So with that, I'm gonna go ahead and hand things over to Jason. And we'll get to find out a little bit about Kubernetes tonight.
All right. Hi, everyone. Hope you're doing well. Hope you all can hear me. If not, please send a message in the chat.
I have my speaker turned on.
Make sure you can hear.
Yeah.
Check. Okay. Good.
All right. So a little bit about myself. Been a software developer for over 20 years. I don't change that number, even though it keeps getting higher and higher because I just feel older and older. I've worked in several industries: healthcare, finance, insurance, telecoms. I've worked for cloud providers, working on their infrastructure. So I've done a little bit of everything. You can follow me on GitHub, where you can see my various doc files and half-cocked open source projects. Occasionally I post on Twitter and Medium. So you can check me out there if you want. And if you want to get a hold of me for whatever reason, you can just DM me on Twitter. So tonight we're going to talk about Kubernetes and specifically containerization and how it can be useful to you from an application deployment standpoint. We'll go over containerization, container orchestration, and Kubernetes specifically, and some of the other alternatives out there. So for application deployments, okay. For application deployments, you know, traditional application deployments came in the variety where you had bare metal hardware, you had your operating system, and then you had your application running directly on top of that. And that operating system is going to be Windows or Linux or some form of Unix or something, but you're going to be running that, and then you're going to be running your application directly. And typically you're going to be beholden to the operating system updates and the system libraries that are installed on that system. We got away from that, and in the last 20 years we've been doing lots of stuff with well, not 20 years, but hypervisors, so running VMware or Hyper-V on-prem or running in the cloud, even where you've got physical hardware that's running an OS or hypervisor level OS that's then virtualizing actual operating systems there, and then running your app inside it. And the big benefit to that is it's a lot easier to spin up a VM on a big beefy machine than it is to request a small or medium-sized piece of hardware. And you get isolation. So your applications can now be dedicated. Instead of having one machine that's running a bunch of different services, you can have several VMs that are each running one service. So you get the isolation. So your blast radius is ideally reduced in case of a security event or a crash, and you're only taking down one service versus your whole infrastructure. Containers bring in a third level to that, and you can do them natively, or most people don't run their own infrastructure anymore, and even if they are running their infrastructure, they're running it virtualized. So this would be most likely running in a VM, but you would have your container runtime. So something like Docker running there, and then each application would be containerized. So it would be running as a container, and it would provide isolation at the process level versus isolation at the operating system level. So one of the things that very important to realize with containers is they're not virtual machines. They provide process level isolation. They do not provide machine level isolation. So there are container breakout attacks that can happen if you don't configure things properly, where someone can get access to the host operating system. Unlike OS level breakouts inside a virtual machine are much more difficult, much more rare. Not impossible, but I haven't heard of any in a while. But you get operating system level virtualization. So process namespace, resource namespace, all those are isolated. And essentially you're going to abstract the host operating system, because you're going to build a package and it's going to say, these are my libraries and dependencies I want for this application. And it doesn't matter what the operating system has installed or not. All that's going to run inside the container. So from your application, it looks like it's running in its own little operating system. OCI is the standard that's come out of all this in the last several years for standardizing these images. And so they are portable across operating systems that support it. Right now, that's Linux and Windows. And the other important thing to note, like I said, it's not a virtual machine, so you are sharing a kernel. So if you have two containers running on one machine, they're isolated from each other, but they share the kernel of the underlying operating system they're running on top of. So if there was a kernel panic, it's going to affect both your systems. If there was some sort of fault in the kernel that allowed a container breakout or something like that, that whole system could be compromised. So just be aware of that. Let's see. All right, so the technology for containers has actually been around for quite some time in various forms. So it kind of started with Unix version 7 at AT&T, I believe, with the chroot command, which is short for change root. So this command allows you to say, for this application, I want its root directory to be some other folder. So instead of my root, just bare / on Linux or C: on Windows, I want this thing to think that the root is somewhere else. And so you can run your application inside of another folder and then kind of make that folder its top level root, and it can't get out of that. So it provides some sort of file system isolation there. And then you could do things like have various copies of system libraries copied into those folders, so you're not tied to the system libraries on the machine. FreeSP jails came out in 2000 and expanded on that concept. Not that familiar with it. Zones and containers came out in Solaris in 2004, and that's really where we first started seeing the concept of a container that we kind of know today come together. In Linux in 2004, the C groups, which is short for control groups, API came out, which allowed this functionality to start existing in Linux to a significant degree. You had the LXC project, which was Linux containers, which was kind of trying to recreate some of the Solaris functionality inside Linux. And then in 2013, you had Docker, which is really kind of solidified what we know about what we all think about containers today. They came up with an easy to use way to define a container, an easy API to use, and an easy format to distribute containers. And it kind of has taken off from there. Unfortunately for Docker, they haven't found a way to make money out of doing that, but a good thing for us. It's now all open standards and changed the world, really. And then in 2015, the OCI, that's the Open Container Initiative, was formed. And that is where we get standards for container definitions, which largely just kind of mimic what Docker originally did, but with some tweaks. But Docker supports it. Various other runtimes support it. So an OCI container provides namespace isolation. So your process and your running inside your container is separated from all the other processes in the system. It doesn't even know that they're there and running. If you were inside a container and you were to, do something to list the processes in that container, you wouldn't see any of the other system processes. You can isolate the network same way, and then file system same way with that root that we were talking about. It does have the shared OS kernel, and there is native support for OCI containers on Linux and Windows. I think the Windows version is Windows 2016 R2 or something. I'm not really sure. I'm not haven't really had to deal with Windows containers, but they do have native support and native Docker support. One thing to note, if you're using a Mac and you're running Docker, it is not native. There is a Linux VM that's running on your computer that's running Docker, and your Docker command is talking to that. When you run it on Windows, if you're running a Windows container, you're running it on Windows natively. If you're running a Linux container, you are also running it in a VM.
What is OCI?
Open Container Initiative. It's the standard that came out to define the spec for what containers.
So who are the contributors to the OCI?
You know what? I'm not sure. I know Docker is one of them. I think like IBM, Red Hat, Microsoft, Google, and all the big guys are on the board there.
Windows has a dependency on WCL or the Windows subsystem.
Yeah, if you're running any non-Windows containers on Windows, and it's going to be running in a Linux VM. So, container orchestration, what do we mean by that? We simply mean we're going to be able to take our containers and run them across a cluster of machines. There are various container orchestrators that have existed over the years. Google Borg is one that Google created and used internally. Apache Mesos is one. Docker Swarm was another. There's HashiCorp Nomad, which is relatively new. And then there's Kubernetes. Swarm came out kind of right after Kubernetes did back in 2014 as a way for Docker to try to catch up with Kubernetes. Unfortunately, the momentum was just not there. Even Docker Swarm is easier to use, but Kubernetes had the momentum. So it's pretty much a dead product at this point. Let's see. All right, so let's talk about Kubernetes. So like I said, it was started in 2014 at Google. 1.0 came out in 2015. I think I started using it in early 2016. It was around like version 1.2 or 1.3. Can't remember anymore. And it was an open source reimagining of the Google Borg project. They released a white paper. I forgot the name of it. And Apache Mesos, those guys read that white paper and then they tried to create it. And that's what they got Mesos out of, which was this big Java engine for doing this. But the Google guys who had worked on Borg and familiar with it, they decided to like, hey, if we redid this and made it open source for the public, what would it look like? And this is what Kubernetes came out with. So it was originally called Project 7 after 7 of 9 from Star Trek Voyager because she was a member of the Borg. And the Kubernetes logo has 7 points in it on the wheel here as a reference back to that Project 7 heritage. Just a quick note on the name, Kubernetes is from a Greek word which doesn't sound anything like Kubernetes. I'm not even going to try to pronounce it, but it means a ship's helmsman. And so the idea is that it's steering this fleet of containers. So what is Kubernetes besides all that fun stuff? It is a distributed scheduler. So it allows you to run your workloads across multiple machines. It has a service discovery mechanism built in. So you can, your services can be running across multiple machines and know how to find each other and talk to each other. It provides configuration management for your cluster. And everything is done through desired state configuration, meaning You don't like write a script that's going to copy stuff and, you know, run commands and stuff. What you do is you give it a definition and say, this is what I want my workload to look like. And it takes that definition and it does all the work until your workload looks like that. And then if anything changes, it is proactively and constantly matching what you say you want to what you actually have and making sure that they always match up. And so that's the way it handles scaling out and self-healing also. So if you have multiple services are running and you say you want 5 copies of a service to run and one of them dies for whatever reason, Kubernetes will see that there's now only 4 and you want 5. So it will start one up to replace the one that died. A cluster looks like this. You have a master control plane, which is running the API, the scheduler, and the control plane controller. And then you have a series of nodes that run a few services. One is called the kubelet, and another is the proxy. And the kubelet is what spins up the work to run on the machine, and the proxy is what allows other services to talk to it through a network. So you do have a software-defined network that runs inside a Kubernetes cluster. So you're not giving out IPs to physical machines, you're giving out IPs to pods, which are containers running inside the service. Kubernetes is what I like to call a cloud-native operating system. So if you think about a traditional operating system, you got your shared resources like RAM, disk, and network. You got your CPU cores that are going to run your code. You got an OS thread scheduler that's going to decide when stuff runs. And then you have your individual processes that have one or more threads that are actually doing the work that you want done. Kubernetes is very similar in that you have the same shared resources. They're just spread across multiple machines now. And then you have a scheduler there that determines where these items should run. And in Kubernetes, your lowest unit of definition for anything is called a pod. And a pod is essentially, it's one or more containers, which in this case would map kind of to the thread model here. So it's the way I see Kubernetes is this cloud native operating system. So a lot of the concepts kind of flow logically, though definitely not in implementation. So our building blocks for building an application in Kubernetes, you have, there's much more than this, but these are the basics. So you have your container. So that's going to be essentially what you want, to run. So you could take your application, let's say you've got a Node.js app, it's going to be running Express. So you would have a container that would have your node runtime inside of it, and then have your application code, all your node modules inside there, and it's going to run your application. It's going to run Express and let's say expose port 8080. So what you would do in Kubernetes is you would when you run that, you're actually running it inside a pod, and a pod says, hey, I want you to run this container, and I want you to give it these parameters and give it this name. And a pod can have more than one container. So you could have your Express app, and then you could have something else that's also running there. Maybe something that you want to, another app that you want to pull your Express app and make sure that it's healthy or something. You could do something like that. So we'll go into details on these in a minute.
One quick.
Sure.
So you would do that if you want those two processes to be in the same box, the same machine, like local to each other.
Yeah, so what happens a lot and where this gets used is something called a sidecar, where you'll have your main container application that's doing the work, and then you'll have a sidecar container that's doing something special for you. So in the case of one of the big examples would be Istio, which is a service mesh layer. And the way it works is it injects a sidecar into your application. So instead of your pod talking directly to something else, it proxies it through the sidecar. And that sidecar is typically used to handle mutual TLS. So the sidecar talks TLS to both ends, so your app doesn't have to. So your app talks to the sidecar talks to another sidecar, which then talks to the app. So they act as proxies with encrypted communication. So from your app to the sidecar is unencrypted, but that's inside this container on the same machine.
And the pod.
And inside the pod, and then over your network, everything is TLS encrypted. So that's one common use for it. There are others. I know GCP has this. They used to do it when you were talking to one of their like Google Cloud databases. They would have a sidecar that would get injected to handle something. I don't remember exactly. Yes.
What is TLS stand for again?
Transport layer security. So
to replace it for SSL.
right. So when you're HTTPS versus HTTP, when you go to a website, you know, and it's encrypted, that's using TLS. Yep. So let's see. So pods are the lowest unit of anything you can define in Kubernetes, but you're not really going to be creating pods. What you're probably going to be creating are deployments, jobs, and daemon sets, and those create pods on your behalf. So a deployment is a way for you to say you want a pod that looks a certain way, and you want multiple copies of that pod to run across multiple machines. With a job, that's something that you want to do one-off and then die. So you could use that to, you know, do an initial setup. You could have a job for that. You can also have cron jobs in Kubernetes. So if you need it to run on a schedule, you can do it that way. And then a daemon set is essentially it's a deployment, but it guarantees that a copy of that is running on every single machine in the cluster. So essentially like a service daemon at that point. Whereas if you have 3 nodes in your cluster and you have a deployment, you're not guaranteed that even if you have 3 instances, you're not guaranteed that they're going to be spread evenly across that. Whereas with a daemon set, you can guarantee that one will be running on every single node in the cluster. A service is really simple. It just says map port A to port B, and that's it. And so we use that to expose your applications to the world. And then finally, the Ingress is a way for you to expose your apps over HTTP to the world.
So services and Ingress, like this is the layer where the IP addresses are assigned so that it can be accessible outside that box.
No. So an Ingress is essentially going to act, the most basic one that is used is it's called the Nginx Ingress, and it literally uses Nginx as a reverse proxy. So it's going to run there and listen on port 443 and 80, take whatever traffic it gets based off rules that you specify, and then map that to a specific container, to a specific pod. When you want to expose something outside of your cluster, you have to use a service, and you would specify what kind of service it is. So there's an option where you say node port, and essentially you would say like 30,000. And then it will make sure that port 30,000 on all those nodes routes to where you tell it to. So you could have port 30,000 exposed on your nodes and then have them route to like port 80 inside your pod. But that's not very handy, right? So there's another concept called a load balancer as a service. And on cloud providers like DigitalOcean, Linode, AWS, Azure, all those, what it does is it spins up the equivalent of one of their load balancers and then maps that to one of those nodes ports that way. So what you do, and the setup that you do is you create an Ingress controller that's going to handle all the HTTP routing. Then you create a service of type load balancer that exposes, that creates this load balancer, and it maps to your Ingress. So what you have is you have traffic coming into, if we use AWS as an example, you have traffic coming into an AWS Elastic load balancer, which then gets routed out to your nodes that are running Nginx on it, and then they take it and they see, okay, well, this was asking for this path and this host name, so I know to route it to this guy over here versus that guy over there.
So Ingress will talk to the services.
Yes. Ingress talks to services, which are just those. It doesn't talk to, but it's those port mappings. Yeah. So I'll show an example of that here shortly. Okay. So If you're going to work with Kubernetes, you've got to love YAML because everything's defined in YAML. You can define it in JSON, but no one does. So it's YAML everywhere. So like I said, the pod is the smallest building block. So this is an example pod. So some of the important things that you have across all Kubernetes resources is you have an API version and you have a kind. So this is V1, it's a pod, and you have metadata and you have a spec. So metadata are important things like, what are you going to call this? What's the name of this particular pod? What namespace is it going to run in? And then any labels. Now labels are very important because that's how you match things up. So, which we'll see in a minute, but labels are kind of like CSS selectors. Well, they're not the selector, but they're what you would select. So in this case, we'll have a selector later on that ties itself to everything with an app, my app label. And then you have the spec. So you can see we have, containers. You can have more than one in there. And so we give it the image that we want to run. We give it some specifications. And then we say, hey, I'm going to run this. I'm going to expose port 3000 out of here over TCP. And then a restart policy of always. So if this thing dies, just restart it. I don't care why, just restart it. And you can define other things in here. You can define lots of settings. This is like the bare minimum. Some of the other things you can define would be if you want to mount storage in here, extra volumes that you can mount in. If you want to say that this container cannot run as root, can only run as this user, and there's all kinds of security things that you can set, which I highly recommend you do set those.
So here in container name my app, which will be mapped to that file. That's a binding between the label and the name my app in the container.
So these just happen to match. They don't have to at all.
Okay.
This I use the convention app. Lots of people do. This could be whatever you want. This is just key value pairs. And then if we look at, I'll show an example in a minute showing how it works. So like I said, with deployments, we kind of talked about this, but essentially they just have a pod spec. Same with jobs and DaemonSets to run stuff. So so here's a service. So let's talk about this for a minute. So services are used for service discovery, and the service discovery mechanism is DNS. So we have a service. We gave it a name, my app. That, once again, that doesn't matter at all. You can name it whatever. But the label on there is also app, my app. So I'm saying the service, I just happen to give it the same label. And then down here in the spec, you'll see at the bottom we have selector. What that is saying here is map this service to all pods that have the label app, my app. And then what it's going to do is it's going to take port 80 and route it to port 3000. So if you remember in our, right here, we're exposing port 3000 because that's what our node app is running on, or whatever app it is. And we don't want to run as root, so we're not going to, expose port 80 or anything under 1024 for that matter. So here we can say, take port 80 and map it to port 3000 for any pod that has that selector on it.
So here we have like 80 is the port which we are exposing.
Yes, yes. Now in Ingress, this is where you get start to get some complication going on in the configuration. So in this example, our spec is saying we want the host header to be myapp.sonicdocs.io. And then we are going to map that. So anything that comes in on the root path is going to get mapped to a service called my app and that port number. So this is kind of where the service, the Ingress is tied to a service, and then the service is essentially tied to a pod. So in order for this to work, on the public internet, like I said, you've got to expose a service to the outside, and you have to have a controller. So if you were to create this resource in a cluster and that did not have an Ingress controller running, nothing would happen. So Ingress controllers don't come out of the box with Kubernetes. It's one that you pick and install. And the easiest one to use is the Nginx one. Amazon has their own that uses application load balancers for stuff. Nginx, the corporation, has made their own, which is different from the one that Kubernetes does that ships Nginx. And then there's one called Traffic, which does some other stuff. Istio has one, and you get all the service mesh stuff to go with that. All right, so I'll show off a cluster. Are there any questions in chat that anyone has? Oh, can't see if I can see it. All right, so give me 1 second to move this over. All right, so I have a cluster already running. So we're going to just check it out. I got a couple things in here running. I got one pod for this application called Greeter. And then I've got one deployment. It's running that pod. And I have one service, actually. I have 2 services. And then I have one ingress. All right. So the kubectl command is how you're going to manage everything in Kubernetes. There is a GUI that you can get, but if you're going to work with Kubernetes, get proficient with the command. And also, I'm not going to type kubectl anymore because I'm lazy. I have an alias for this, so I'm just going to type K. So here's all the pods running in the system. We can see my one pod is running on the default namespace, and then we have the Ingress controller that I'm using has 3 pods running. Well, 2 are not running. This one is running. These were jobs that completed. And then the Kubernetes system is running various things. I'm running this on Linode, and so they've added Calico and CSI. By default, you would just have like core DNS and kubeproxy running, and that's about it. So they kind of did some setup for me so we can use Calico as our networking layer. Let's see. So if we let me bring this over. So if we bring this over, we can look, here's my deployment. So I have an app called Greeter. And it's running this particular image on this port. And then I have a service that's running here, and it's connecting this port to port 80. And then I have an ingress here that's taking this URL and running it. So we can actually hit that URL. Let's see. Type. And then I have an endpoint called version. So that's actually the SHA commit that is deployed there. And then I can hit another endpoint that I have called hello, I believe. Yes. And it tells me, so I have this application, it's just a basic Go application that serves these 2 endpoints. The hello endpoint, each instance gets its own, will generate a unique GUID and return that. So since there's only one instance running, you can see it's the same GUID every time. So we can do things, let's see, we can say, I want to scale this deployment. and I want it to run 3 copies. So I tell it to change the number of replicas to 3. And then let's see it scaled, and then we can say get pods again, and then we'll see that it's already started. This one's 4 seconds old, it's still creating. This one is also 4 seconds and it's already running. So now if I run that curl command again, I'll start getting, you can see now I'm getting different IPs because the service is acting like a basic. So there's a load balancer that's the ELB, but that's hitting this service. So that's acting as a basic round robin load balancer in the system as well. The other things we can do instead of, sorry, I've been working and stuff. Typing one command. I can edit this deployment directly. It's going to fire up Vim. I can come in here and I can say, you know what, I want 5 replicas instead. All right, so now I can get pods. So this is how you would work with Kubernetes, is not necessarily running these commands, but you would have this YAML getting updated by your CI system or deployment system. Ideally, you've got this checked in somewhere and it's all automated, so you're not at a terminal running commands when you're doing a deployment. Some of the other cool things you can do, let's say I've updated config and I need to restart this service. Let's see, we've got these pods running here. Let me bring the terminal up and show you over there. Let's see. Oh, that did not do what I thought I was going to do. All right, so that's going to be just updating the pods, and I'm going to simulate this one getting crashing. So I'm going to say, okay, delete pod. All right, so it died. It's terminating. You can see we've already got a new pod spinning up because Kubernetes, we told Kubernetes we want 5 copies of this. So just because I went in here and I deleted one, okay, I deleted it. Kubernetes doesn't care. It's going to delete it because I told it to, but it sees, oh, wait, this one just terminated and he wants 5 pods. So I'm going to run 5 pods. If I were to say I need to restart all my pods, I could get my pods and then I could delete them one by one, or I can do this. I can say restart this deployment, and then it's going to kill them kind of one at a time. You can specify in a deployment the max number, your minimum number of pods you want running at any one time. So it's not, it's not like it's going to kill all of them at one time. You can, have it essentially do a rollout where it takes one out, builds a new one, puts it back in. So you're not suddenly like down, right, for a little bit. Yes.
So thinking about a production environment, like can you have it say, hey, I want you to make this one, let's say you have 5 pods running. I want this one pod to be old. So like, hey, or I want this one pod to be new. Like you're testing out something new before you release it to the rest of everyone. Okay,
so you want to essentially change the software.
Yeah.
Okay, so in that case, what you would do instead of doing, you would essentially create 2 deployments and just have the same label on them. So the selector will match to both deployments. And so you could have a deployment that was running version 1 and a deployment that's running version 2. And since your service is mapping on those selectors, it will route to both. And then the traffic will randomly hit version 1 or version 2 if you want to do it that way. So you could do like basic A/B testing by doing that.
Okay, cool.
So we can also get some information about the nodes in our cluster. The nodes are the actual compute units here. One important thing to note though is I'm not, I don't really care about these nodes, right? They're just boxes that run my code. I care about them in the sense that I want my code to run and they need to be powerful enough to run my code. I don't care anything else about them. I'm not going to connect to these machines. I'm not going to SSH into these machines and do stuff. If you're running your own cluster in your own data center, you might find yourself in that situation where you're SSHing into a machine to figure out some problem or something. But ideally, you're not fixing that server. You're fixing your configuration of your deployment of those servers and then redeploying a server. So if something's wrong on one of these machines, you don't want to fix it. You just want to shoot it and get a new machine. And so,
say you want to install a set of patches across your nodes, right? So what you're essentially doing in an Android VM scale set, you might just blow away the old VMs and spin up new VMs with new limit. Maybe do it in a staggered way.
yeah. That's what I would recommend. So for those, if you didn't hear the question online, how would you handle like patch management and upgrades? And essentially you would start deploying new nodes into your cluster that have the patches and the updates, and then you would start shooting the old nodes. You could roll out, those patches to those machines, but it's much better if you just use a desired state configuration from the whole get-go, even for your infrastructure, where you say, I want a machine that runs version X, and you let your whatever system you're using there to schedule it. So if you're going to run this in your own data center, and you're not going to use one of the cloud offerings that handles this, I would highly recommend you use Rancher. It essentially gives you kind of all the functionality that you would get with like EKS or Azure or any of those. And you can actually use Rancher to manage those clusters as well. It's open source. If you want to pay for it, you're paying for support. It works pretty well. You can get like LDAP integration, Active Directory for logins and stuff, but you can use that to manage your fleet. It's pretty good. VMware has a solution. VMware bought Heptio, which was one of the first companies that spin out of this project, and they were offering Kubernetes consulting back in the early days and support. And they also created some products like a node backup product that would back up your node, not your node, but your cluster configuration. And VMware bought them. And so they have a lot of support, and they're building a lot of Kubernetes management stuff into the VMware UI and those things. So if you're going to run it yourself, Rancher, VMware, but I recommend not running it yourself if at all possible. And if you're in the cloud, use what the cloud you're in offers. You can spin up your own cluster in like AWS or Azure using something like COPS to manage it. But then you're completely managing it. You're managing all the instances. You're managing the upgrades and all that. Whereas if you use EKS or AKS, they're handling that. You're going to pay a small fee for the control plane, but you don't have to worry about the control plane. They're going to guarantee it with an SLA. Whereas you have to guarantee that yourself if you're running the control plane yourself. Yeah. Any other questions? Okay. I'm trying to think if I can think of any other things to show. I mean, this is a very, very basic Kubernetes introduction. If you have any questions, or if you want to kind of go deeper, I'm more than happy to hop on a phone call or a Zoom or anything with anybody if you want to talk about stuff. If you got scenarios you want to go through on how you can use it, or you're stuck in a problem, feel free to hit me up.
Let me ask one question. So if we're just trying to learn this, would you recommend just trying to run it on a local machine when you're getting started, or as far as like if you want to start playing around with it like on like multiple machines, like a real cluster, like what would you suggest, like Linode, or
So Linode is good. Linode and DigitalOcean have a very cheap option. But you're still going to be, I think the cluster that I'm running is not the cheapest cluster. I think it's like $90 a month. So it's not the cheapest. So I'm going to be killing it right after this demo.
What host is it?
This is Linode. They're very much like DigitalOcean. The pricing is virtually identical. DigitalOcean has a service, but you can run a much cheaper one. I just happened to not be paying attention and I spun it up and I was like, whatever, it's only gonna be like $5. I don't care for one night's worth of usage. Yeah, Azure has AKS. So if you have like Azure credits or Amazon credits, you can use their service. If you want to run it on your own machine, Minikube is a pretty good resource, and essentially that will run a virtual machine on there for you and get it set up. Ubuntu, if you have an Ubuntu box or Ubuntu VM running around, they have a package distribution called MicroK8s, which is very similar, but it's for their service. And there's also a service called, it's pronounced keys apparently, but it's K3S, which is it's a distribution of Kubernetes. It's fully certified as a Kubernetes distribution, but it's meant for kind of like edge computing. And but essentially it's one executable you download and it sets itself up and it runs, and you can actually run a whole cluster. So you get a key. So you set up one machine and it's going to be the master, and you get this key, and then you set up all your other machines and you just say, hey, here's the IP of the master and here's the key from the master, and it auto joins everything. And so you could very easily set up a cluster. So if you had like a bunch of Raspberry Pi sitting around, it runs great on a Raspberry Pi. So if you had 3 or 4 old Raspberry Pis that are sitting in your closet and you haven't done anything with, build a Kubernetes cluster out of them. Very easy. It's very popular. Jeff Geerling, who does a lot of stuff with Raspberry Pis, he has a whole guide on setting up a Pi cluster for you to play around with. So I've got some home automation stuff that I'm trying to slowly work on when I have free time, and I'm probably going to be running it inside something like that. I got some old machine that's sitting there. I'm going to throw K3S on it and run my home assistant and some containers and stuff. So if you want to learn it yourself, Minikube, K3S, or if you can get yourself some credits on one of the cloud providers, spin up an instance. You don't have to leave it running all the time. So they spin up very quickly nowadays. So spin it up, play with it, kill it. Spin it up, play with it, kill it,
Did you say Rancher does something like that?
Rancher is essentially, they have their own distribution of Kubernetes, which you don't have to use, but it is essentially a way to provision a cluster. So you could provision on AWS, you could provision it in your own infrastructure. I worked for Ultimate Software for a while, running getting their Kubernetes stuff up and running, and we used OpenStack, which is a horrible piece of software used to manage infrastructure. And essentially it's AWS in a box written in Python that you run across your infrastructure, and it spins up VMs, and it's super slow. But we ran Kubernetes on top of that, and we used Rancher for provisioning of those clusters. It made things so much easier than we had automation with Terraform and stuff. And there's tools like KubeADM to help set all that stuff up, but use Rancher. Like, unless you want 100% control of everything, use a tool like Rancher, because it's very tedious. There's all this config that you have to get right, lots of TLS setup you got to get right for everything to be secure, where these tools just do it for you. So please, unless you want lots of heartburn and pulling your hair out, use one of these tools. They make things so much easier. So glad they exist. When this first came out, it did not exist. There was like a README in the repo, and it was kind of, it was painful.
So one other question I was going to ask related to the scenario where you mentioned like you have all these extra Raspberry Pis and stuff like that. Now, I know that there was a change that was made to Docker a number of months ago where you can create containers for essentially different architectures. So for instance, like if you're doing x86, or I guess x86 64, or if you're doing ARM or whatever, you can actually create a container or whatever that will support multiple architectures. And you were mentioning earlier that Kubernetes, supports other things besides just Docker. And I was curious what the equivalent to that, like if you wanted to deploy something with Kubernetes onto Raspberry Pis, like how would you go about doing that with containers?
So for using Raspberry Pis, go with K3s to deploy Kubernetes. It has ARM support out of the box. So if you're doing it yourself, you're going to have to get the ARM builds of everything and run it and set it up. So K3s all the way if you're doing a Raspberry Pi cluster. And the cool thing too is you could actually have a cluster that consists of multiple different architectures. So you could have your Raspberry Pi cluster that's all ARM, and then you could add some x86 servers into that cluster. You'd have your nodes that would join into the cluster. If you're using K3s, that's super easy. And then the problem then is you've got two different architectures now running. So you don't want it to try to schedule your ARM architectured code onto an x86 and vice versa. So there's a feature in Kubernetes called taints and tolerations. Horrible name, but that's what they went with. Taints and tolerations. So, and I always get it backwards. So essentially you specify on a node what it can tolerate, and then you taint the deployments or pods. So it's kind of like the labels and selectors. So you could have your nodes and say, these are x86 nodes and these are ARM nodes. And then you could taint your workflows to say, this is an x86 workflow or an ARM workflow. And Kubernetes won't schedule that on your x86 box when your ARM workflows. One good usage of this is if you're doing anything that has GPUs in it, okay, you want to, you don't want every cluster, every node in your cluster to have GPUs because GPUs are expensive, especially now. So if maybe you only have 3 machines that have GPUs in it that you want to use for some, rendering or some machine learning training or models or anything like that, you can say, these are my GPU nodes, only run these certain workflows on it and reject any other workflows. So then you'll taint your workflow to say, this is a GPU workflow and it will run over here, and then it won't run anything else over there. So you're not wasting compute cycles on this machine to run just a node app, right? You're running your model generation or whatever it is you're doing on your GPU there. So that's another good use. So you can have a cluster. Your cluster doesn't have to be homogeneous on its nodes. So there is no concept of a node group in Kubernetes, but most of these provisioning engines like Rancher have that concept they add on top. And then tools like EKS and I think AKS and GCP, they have the concept of node groups. So essentially it's kind of like an auto scaling group. Here's a node group. It's all the servers look like this, and I want 10 copies or whatever. And then I've got another one. I want these servers to look like this, and I only want 2 copies, right? So you can have your GPU clusters. You can have really high compute nodes. You can have all that inside one cluster, and you're just kind of specifying different config. And then what you would do is you would add those taints and tolerations to prevent, workloads, to schedule them to the right machines.
So in a real world example, right? I haven't, our clients, they use Kubernetes and all. There's a lot of churn because of that. But in reality, especially within the enterprise, I mean, if you have a public service, yes, you cannot predict the load. Sometimes you get hit with them. But within the enterprise, I've never seen a sudden spike, or maybe I'm not watching when it happens. But so is there a benefit to this other than autoscaling? So if autoscaling is not your
Right.
use case, then what are the reasons?
So I actually haven't shown anything with auto scaling here. The scaling I did was manual, where I said scale up to 5 because I want 5 copies. There are add-ons that you can put on here. One's called the horizontal pod autoscaler, and what it does is it analyzes the usage of things, and you can set a min and a max, and it will scale your pods out. That way, there's also things that you can do where it'll add more nodes into your cluster as needed. If scaling is not really an issue, so the question to me is, if scaling is not really an issue, is Kubernetes still worth it? And I would say yes, because it makes deploying your application and managing that a lot easier than if you are like deploying a traditional way. So like if you have, a fleet of Windows computers and you need to deploy an ASP.NET application and you're copying stuff over to some folder in IIS, right? And then restarting an app pool and all that kind of stuff. It's been a while. I'm really reaching into my memory to remember the stuff. There's ways to automate it. There's tools around that, but they're not standard. So if you in your fleet have a couple of .NET applications, and you've got this legacy Python application, and you guys acquired this other business and all their stuff is written in Ruby on Rails, right? And you need to deploy it all. You don't want to have 10 different ways to deploy stuff. So with Kubernetes, you can deploy it one way. You say, here, it's in this container, and I need it to look like this when it deploys. And so you could have a Kubernetes cluster of a mix of Windows and Linux nodes, and you could deploy your Ruby on Rails to Linux, and then you could have your .NET application still running as a Windows container. You don't even have to port it to Linux if you don't want to. I recommend you do, because it'll probably run better. But if you need to run it on Windows still because you haven't ported it, you can have those Windows servers as part of your cluster and deploy it that way. So it's going to take the load off of your ops team for sure, because now they have one thing to deal with, right? They work with the cluster. They don't work with all these different disparate machines and different deployments. They work with the cluster. Everything is a container, so they don't care. So the developers are packaging everything up. And so, you're not worrying about, do I have the right version of Ruby? Okay, well, this machine, I have to run Ruby 2, and this machine, I have to run Ruby 3, stuff like that, right? So your container this is a Ruby 2 container versus a Ruby 3 container. And guess what? They're running on the same machine, and the machine doesn't even have Ruby installed, right? So there's none of that stuff that you got to deal with.
So so I was
IP address is also, it's not the machine IP address you will give out, you will give out the container IP address, which is like a separate.
you'll give Ingress whatever public IP.
Yeah. So if you want your services to talk to each other and they're not exposed to the outside world, you're gonna those service names that we had here. So I've got a service called Greeter. That is going to be a DNS name inside my cluster. So the full name, since this is inside the default namespace, the full name is greeter.default.svc.cluster.local, I think, something like that. No, .cluster, not local. So if you want to use the fully qualified name, if it was in a different namespace, it would be greeter. Some different namespace, whatever. But that's how you would do everything. So every pod that's running inside the default namespace on this cluster here can talk to that greeter service simply by using the DNS name of greeter.
Basically, using the Kubernetes is easy to communicate between the application, between the services, once it applies separate.
Right. So obviously, Kubernetes is on the higher end of deployment and scaling and all that. The lower end is Docker Compose.
Right.
So Docker Compose gives you almost all of those things except scaling, I think. Even actually it does have scaling also.
If you want to run it across multiple machines, you're going to be using Docker Swarm. And it uses a compose file for its definition. But what I understand about Swarm is essentially it's pretty much dead, and they're not really like Docker's like Kubernetes won, Swarm lost. And I don't think they're like really enhancing it. They might support it for a while longer, but I think they're trying to focus on other things now. So Docker Swarm was easier to use. for some use cases, and for local development. It's great. Like you can spin up all your databases. You can have all your stuff running and doing that locally. Even though we're running everything in Kubernetes, where I'm at, we still do our local development with Docker Compose because it just makes things super easy. But when we go ready to deploy it to dev, like that endpoint you're hitting, that's running in Kubernetes. So it just makes things simpler from that standpoint. But the core unit between both these is the container, right? When I run the code locally for a different service that I don't care about, I just want the service running locally. I'm running the container. I'm not pulling the code and running the code. I'm just going to run the container, and it's going to run the same on my machine as it is on his machine and your machine and her machine and in production, which is the biggest benefit of Kubernetes is, or not Kubernetes, but Docker and containers is it works on my box excuse goes way down, right? Because it's there's very few things that are different now between my box and production, right? Some of the config I gave to the container is different, right? But that's easy to find, hopefully. So then really what's the difference? The version of the Linux kernel? Okay, well, I mean, that's pretty stable. And, if this isn't working, I doubt it's a kernel issue. So it makes it a lot easier to debug stuff too, because hey, it's the same thing running here as it is there.
I know there's a Kubernetes menu now in Docker Desktop. I've never used it, but
Yep.
I've seen it there.
So yeah, that will spin up that's another way to do it locally. I forgot about that. On Docker Desktop, it will install Kubernetes for you inside that virtual machine that's running. Excuse me, and you can use it that way also. I haven't really used it much, so I'm not that familiar with it. I know they added that. They added that a couple years ago, I think, but I don't know how it's come. Docker's been kind of a resource hog on Macs, so because it's running in a VM, right? And it's not really an optimized VM that much.
Should we, we can continue the questions, but should we also do some introductions because we have a couple of new faces?
So is based on
OpenShift is built on top of Kubernetes.
All right, I'll go ahead and get started with introductions with myself. My name's David, and I'm the co-organizer for the JaxNode user group. And I primarily do mobile development, but I love Node.
Hello, my name is Anthony. These days, I'm currently working on serverless and AppSync. Yeah.
Serverless and AppSync, did you say?
Yeah.
Interesting.
I'm Brett Causey. I'm a software developer at Spinspire. Yeah, that's pretty much it.
You want to tell them what kind of work you?
A little bit of everything. A little bit of everything.
Okay, so I'm Aditya, and I'm working in the node technologies, including React, and I work in Active as well.
Awesome.
I'm Nilesh. I work here at Spinspire, and I get involved in every project everywhere, so I kind of a lot of diverse experience. Mobile, web, infrastructure, AWS, serverless, everything. But and I love to talk to people who are working on.
Awesome.
I'm Brian. I've just been in JaxNode for several JaxNode. Probably some of the first one I've been to since COVID. I think the last one I was over here, this represents Sub, which is but then
Yes.
Yeah. That was pre-pandemic.
Yeah, it's been, exactly. Yeah, I got started in 2019. So.
I was vice credit union. I'm an application developer and actually work with mainly our microservices for the digital banking project. We actually use service fabric. We actually use Microsoft we actually use Azure Service Fabric for to host our microservices. But we're talking moving away from service fabric. Kind of remember this work from Microsoft on. Not that it's going away or anything, but apparently the people that are at Microsoft, the service fabric engineers, are tied up doing stuff internally for Microsoft. So doing about support courses. It is open source. It is full platform. Just kind of targeted to get those guys. So we've been talking for like the last year or two about moving, migrating away from service fabric and going to Azure Kubernetes systems, which in some ways is a little bit like a step backwards. In terms of management, in terms of complexity of management, because the service fabric, you just push, you just push up into the service fabric. You don't even have to have service fabric here for you. So that's kind of one way to discuss this from this particular session. Kubernetes how that works.
This is everybody?
Vice President.
Why?
We're actually a TIA. We're a TIA.
I'm a customer, so thank you very much.
Oh, yeah, I have to say that. My experience with Vice President is very good, like any other one.
Our new digital banking system will be coming along soon. So hopefully you guys enjoy it.
I'm community first, sorry.
Yeah, hi, my name is Christian. I work here at Spinspire. Kind of like Nitesh, I wear a lot of hats. A bunch of PHP, a bunch of React, a bunch of Linux, basically everything you can think of.
Salesforce.
Salesforce, yeah.
Sorry.
Yeah, me too.
And online, I see Scott Felder. I don't know if you can, okay.
Can you hear me?
Maybe.
Can you hear me?
Oh, I better turn this off. Yeah, I was muted. Sorry about that, Scott.
You hear me?
I can hear you.
Scott Feller, self-employed contract developer. I work on all kinds of stuff. A lot in the Microsoft space, Azure, AWS. Right now, I'm doing embedded Linux for some IoT stuff for a client we use. We actually use Swarm on the product we produce. Runs in Azure, AWS, and on premise on Windows servers, and we use Swarm for the containers on Windows. Kubernetes on Alibaba. So kind of a whole mix of stuff.
Awesome, thanks, Scott. And I also see that somebody here, CMAT.
Chase.
That's Chase.
That's Chase?
Yeah, it's Chase.
Oh, okay. Hi, Chase. All righty. Well, thanks everybody for coming out. Really appreciate it. Really appreciate it.
I didn't mean to end the conversation.
Well, I was going to end the Zoom. So, but thanks everybody for coming out, and thanks Jason once again for coming out and do the presentation. If anybody's interested in doing a presentation for us, just please let me know. And with that, I'm going to end the recording. Have a nice evening, everybody.